everyone. This is Jill Hurston from Accelerate. Welcome to episode 24 of Zip Chat. So, with that, I'm going to turn this over to our host, Mike Watson. Mike, it's over to you.
Thanks, Jill, and welcome everyone to today's Zip Chat, which is episode 24, AI and Healthcare. Today, we're going to talk a little bit about how AI can be applied in the healthcare space. Now, knowing that AI itself is a big topic and knowing that healthcare is a big topic, it's like two huge sets, and we're going to try to find a convergence of the two that makes sense for everyone, and and try to make some sense in there, because there's a lot that we could talk about. So we're just going to narrow that down a little bit. With me today, I have Anand Raghunathan. I think hopefully I got that right. Close enough. He's the Chief AI Officer at Unscramble AI. And then I also have Lori Myers. She's SVP of Healthcare here at Accelerate. Great to have you both here. Let's just dive right in. So Lori, just to narrow it down a little bit, right? Let's just today focus on providers, right? So I think providers have a lot of need. I think we can get a lot out of just talking about the provider side. Does that make sense to you?
Yes, it does.
So with that, what are the current state of things in the provider world? Like, where are the kind of pain points, and what's going on there?
So thanks, Mike. Just to kind of level set, when we say providers, that's a lot of organizations and people, hospitals, large health systems, outpatient clinics, your primary care physician, your specialists, ambulance services, you name it, labs, imaging. So all of those entities have data on their patients and their members and people that they serve. So the data is increasing exponentially day over day over day. So the challenge is, from a personal perspective, how do you make sure not only that each of your individual providers has access to all of your data, that you have access to all of your data? And so that's like getting everybody to talk together, to exchange data, to look at it the same way. And we're moving in that direction, but it's a huge challenge. And some of the pain points are every organization and every entity is doing the best they can with using their own technology, and the technology doesn't work in the same way from organization to organization, and the data governance and structure of the data is often very different. Something as easy as street, your address, abbreviation for street, do you write the word street out, and making sure everything can link up. So, and then are there missing data elements and those types of things? So just dealing with some of the pain points are just the sheer volume, and then being able to extract it and integrate it across the platforms are big issues. And this is a lot of area where AI and machine learning can really help, because you can kind of do the extraction and the translation and loading so with a pattern and make it happen faster. And then there's always the other consideration that many of the providers are still doing handwritten notes, annotations to documentation, those types of things. And that's a big opportunity for AI to capture that unstructured data and put it into a structured format so it can be consumed. Amazingly enough, current studies have indicated that as high as 80% of the data in the healthcare ecosystem is still unstructured, meaning that it is these handwritten notes, it's these annotations in a medical chart that are important for driving decisions. But in order to drive the decisions, the data has to be consumed and put into the process. And that's where we're heavily reliant on AI and ML.
Gotcha. So Anand, you probably have been talking to several healthcare organizations in your efforts to figure out how you can help the industry. What other challenges are you seeing? I mean, Lori mentioned unstructured data. I mean, do you see, let's dive deeper into unstructured data. What are you seeing there?
Oh, indeed. So the challenge is both in the structured data side as well as unstructured data side. So just an example, just a few weeks back, we were working with a data set from actually in this case an insurance company, but the same kind of situation happens even the provider side. We work in a data set where there were about 20 different ways in which the company CVS was represented. So in some cases it's called CVS. There's another case that's called CVS space group. Other place is called CVS space GRP, CVS GRP. So there was this is incredible. Just in one data set, how many variations of exactly the same entity there were. And this is in a structured data set, right? And that's for one data set. And the problems multiply when you have multiple data sets potentially in different silos across different organizations. So to match that, say a given person, say with a given street address, having a certain insurance provider, is the same as another person, another person in a different data set with similar properties, is a big challenge. So that's on the structured side. And the same thing applies on the unstructured side as well, because there are so many ways of representing these concepts. And so extracting from let's say an insurance card, who is the actual what's the actual group number, and what's the actual insurance company, is itself a challenge, because sometimes say Delta Dental Iowa is slightly different from Delta Dental Connecticut, for instance. Even though they're the same parent organization, you need to make judgments on are they the same in a given context or not. So across the board, there's lots of challenges in extracting data from both structured and unstructured data sources and merging them all together to create a holistic view of the world.
Yeah, and I imagine like trying to report on that kind of, like in the structured example with the same name, like how many people use this pharmacy, right? Like that question can't be answered at all unless you make really complex logic to join those kinds of things. So I can see how that would be a big problem.
And that was a really good example about Delta Dental within one organization defining one data field multiple different ways. So when you add on to that the providers have to use the patient's insurance cards. If the patient, they're treating a variety of patients, but their insurance is anywhere from United, Aetna, Anthem, whatever, all of those cards are different. All of that data means different. Their name may be on the card, the patient's name, but then they have a different member number, they have a different, group number, and each organization lays their card out differently. So it's sort of the same information, but in different places, conveyed in different ways. It's like being a translator at the UN.
Yeah, that does sound like a tricky problem. And then of course, when all of us have filled out forms, right? So it's like they want a copy of that card, but then it's like fill it all out manually too. And this is just
right.
a total pain for us as consumers.
In fact, one thing I've seen kind of common whenever I've been to many providers is they don't even care about the name anymore of the company, but the phone number. In many cases, the phone number becomes the ID, because they know that, okay, fine, a 1-888 something 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 is, say, Blue Cross Blue Shield Arkansas versus Blue Cross Blue Shield Kansas versus Blue Cross Blue Shield Minnesota. All of them will have their own phone number. So it's interesting that people have come up with creative ways of disambiguating different organizations.
Yeah, so let's kind of dive into so that's kind of some background. Let's talk about AI, and it's interesting. I've worked on a lot of systems, or maybe I've in managing systems that have AI components in it. And there's a couple of big parts of it, right? So there's the capturing of the data and loading it into some mechanism that where you can churn on it. And then there's, the actual machine learning or, processing, whatever type of AI you might do on that data. And then, there's connecting that into applications in a powerful way, right? So there's like kind of these three elements. So let's start with the first, which is probably, equally most important element is the data capture, right? So let's talk about how AI can help there, because I think there are ways that AI can help there. So Anand, what are your thoughts on how AI can help in data capture?
Sure, yeah. So firstly, there's both structured and unstructured information. So on the unstructured side, there are so many different mediums in which data is present today. So as Laura is mentioning, there's handwritten, handwritten stuff in as part of forms being filled out in paper very often still. There's images coming from, say, lab work or other sources, and some of them also are video or even have video and audio components these days. So there are lots of technologies now to be able to extract some structure from these different sources with caveats on their accuracy and precision. But there do exist technologies to at least do OCR on handwritten say notes or other formats. There are lots of image and vision algorithms for extracting, from radiology or from MRIs, key elements that we want to extract out. So that's one class of data capture applications from unstructured data. A second class is from the structured side. So being able to, at different parts of a patient's journey, being able to capture what happened at every visit, every interaction, and have it all be present in a single fashion is critical, because now in different parts of the journey or the patient's journey, the data might be recorded in different systems across maybe different providers, different payers, and it's sometimes difficult for one person to say, okay, what all happened for this one person across a period of time. So yeah, so challenge is both multiple formats and multiple sources, and then bringing it all together, hopefully into one place, maybe in some centralized or distributed fashion, bringing it in one place where it can be accessed by all relevant parties in a safe and secure manner.
Yeah, that all makes sense. Laura, anything you want to add to that?
Yes. So you had mentioned the patient needing to fill out multiple forms, and I think we can all, as having gone to physicians, relate to that, having to present our insurance card and some form of ID, whether it's a driver's license or passport or green card or any kind of state or federal ID, various different formats. But you have to do that every time along your patient journey, from the point of registration, seeing your PCP, and then setting up any kind of diagnosis testing, engaging even other physicians. And AI could really help streamline and synthesize this process by using OCR and imaging process, capture the data, send it, structure it in such a way that it could then be parsed out to the individual medical management systems, because again, all these different people may or may not be on different systems, but parse it out as a single point, a single source of truth, if you will, and then cascade it across the organization so the patient can then focus in on what they need to focus in on, and the physicians can focus in on what they need to focus in on, as opposed to all this manual data processing and manual paperwork. And then if you move, you can just update it once, and the information would cascade automatically across the ecosystem. So that's the power that's potentially available at AI is that all of a sudden we're starting to capture the data, have it readily available, have a single source of truth, and have it available for everybody who needs access to it.
So do you think in this particular case, AI would be able to connect the dots, like this person is actually this person we have on file versus a different person? I mean, is that really where the heavy lifting is for the AI in this scenario?
Right. So there are lots of different technology come into play for AI over here. There's the extraction of structured from unstructured data. So OCR, image recognition, machine vision, and so on. Then there is the linking, as you said, whether this person is same as this other person or this entity is same as this other entity. There is also a use of AI for being able to search more effectively. So, for instance, when I ask today, for instance, we've taken for granted Google as one way of searching across at least the public web. But there's no way of searching across, you could say, the health web, which consists of all these different data sources across different silos. So if I had to ask a question today on, about a certain visit of mine, a year or two back, I don't know where the data is present. I know who's holding the data. I don't know how to ask a question. I don't know, do I have the permissions or who should I get permissions from? So AI could even help in taking my question or my data request, and figuring out where is that data present in the first place. And if it figures that out, then how best can it somehow answer my question automatically, given my conditions or given this, depending on the security I have, the permissions I have to access the data. So AI could even help in the search process and in making it easy for end users, whether they're patients or doctors or providers, payers, and so on, to be able to access data in a more seamless fashion.
Makes sense. So, when you're thinking about building an AI component inside of this, like what's the most important thing about the outcome? Like, Lori, what's your thought on that?
Well, from my perspective, keeping the end objective in mind, which is how you're going to use the data and for what purpose you're using the data, which is often reporting business intelligence and outcomes, reporting on clinical outcomes. Are you getting the results that you're looking for? It really gets back to capturing the data and storing it in such a way that it's consistent and usable so that you can make data-driven decisions from it. So that's kind of the objective and the purpose that I come to, looking at how can AI facilitate that, make it happen more efficiently and faster. Because right now, everybody's trying to do it manually. And it's just, it's too big. It's like wrangling an 800-pound gorilla. So let's use the technology that's available to us to do that.
So you mentioned go faster, but also like come up with good insights, right? Like make actionable insights from that data. Like that's ultimately where I think any AI system, right? Like that's what you want, is to figure out, what problems can I solve with this data? How do I make How do I make my business better? How do I make the patient's, in this case, the patient's experience better? Those types of things.
Yeah, and I can give you a really good example of how we would use a use case for using AI. So in the healthcare system, and particularly on the provider side, which is really kind of what we're focusing in on, patient goes to a physician, they've gone through, different tests and different, clinical assessments. And the physician has recommended either, a surgery or an advanced imaging or a specific pharmacy step therapy, all very, very expensive. So before they can do those particular treatments for the patient or the diagnostic test, they have to ask for permission from the insurance companies in order to just do the medical necessity and justification. And that process is very heavily manual, is a manual process. It's very labor intensive, and it takes anywhere from 2 to 3 weeks. So the patient's anxious to move on, get the diagnosis and get the treatment that's needed. The insurance company wants to make sure that there's all the checks and balances and it's not unnecessary, and we're just not trying to inflate the cost. And the provider's wanting to do the right thing and treat the patient. So, we're trying to get everybody together. The thing that AI can do is capture the data that is available in the electronic health record, capture the doctor's analysis process and what the medical justification is. And if the clinician is writing this out, they can use OCR, they can use a data capture, turn that data in, create a template and turn that unstructured data into structured data, append that to a pre-populated data form that can be electronically sent over to the payer and get that into the approval process. AI can also help with doing what was the disposition that came back, what is the turnaround time, and be able to compress that timeline so that we can move the patients along the care continuum. And then and AI can also say, help us capture, okay, this is what happened for this diagnosis, this treatment plan, and here's what the recommended, additional requirements were. Get ahead of that so that the next patient that fits that criteria, we're not going through the same process again. We can get ahead of delivering that information. So we've now compressed the 3-week time frame down to days. So then we can get the patients moved. And so it becomes far more timely, which has been indicated from studies that the faster you can treat patients and diagnose them and get them into particular care plans, you get better health outcomes. So we're reducing costs, we're getting people better and healthier, and we can do it in a faster, better way. And we're supporting our clinicians in that they can now focus on real complicated things while we are, they're not needing to do all this manual work any longer. So it's a win-win for everybody.
Yeah, that's interesting. I was just remembering a horror story of me trying to get a scan, and the wrong code was used or something, and I was like back and forth, and I had to reschedule multiple times because I'd show up at the appointment, you don't have everything you need, so you have to go back to your doctor, and like couldn't get a hold of them in real time, and so avoiding all of those kinds of things would be nice. Maybe it wasn't unavoidable in my case, but if an AI system can tell you need these 3 things typically in order to be successful, and you only have 2 of them, that would be interesting information. Whether like I say, in my case, it was going to the provider and they needed more information from the prescribing doctor or whatever you call that.
Right, the ordering physician, yeah.
But also, like you were saying, for getting approval of that particular charge.
Right, and as much as, you as a patient, you're calling the doctor going, well, when are you getting me in? When are you getting me in? When are we getting this done? The doctor can't do anything. They run the risk if they go ahead and provide the service, even if they think that it's, absolutely, time is of the essence, they run the risk of not getting reimbursed from the insurance company. And so then you're impacting their revenue cycle, potentially throwing the liability back onto the patient. So it's important for everyone who is a key stakeholder in the process to make the process better. And we can use AI to do that.
Yeah, that's cool. That actually is a really great scenario. So Anand, you work in this space and you try to help hospitals and other providers get better information, more readily, right? So can you describe the use case that you're operating in the health tech world?
Sure. So our product is in the natural language processing, especially in the natural language query space, where we allow users, especially non-technical users, to be able to ask questions on data using plain English. And behind the scenes, our NLP technology translates those English questions or English queries into SQL queries or into Python code that can extract data from one or more databases and then prepare the answer and explain the answer in natural fashion using charts or using natural language as well. So common examples are hospitals asking questions like, what's the average bed occupancy rate in the maternity ward in the months of January and February each year? So that kind of information is typically might take hours, if not days, for data analysts to prepare a report for. But the goal is that if the hospital administration could ask those kinds of questions in English and get back the answer immediately, then they can take decisions much faster and adapt quicker to either, say, in this particular example, say spikes in demand for certain kinds of resources or of procedures at different times of the year. Another common example that we worked on is hospitals asking questions around which kinds of claims are more likely to be denied than others, and which kinds of claims are the ones they should be spending more time to fight with the payers, and which ones should they just give up on, for instance. So again, machine learning and AI can help in understanding the pattern of claim reimbursements and denials, and help people make better decisions on what claims should really be reimbursed, and if they're not reimbursed, if they're not being denied, what are the key causes why they're being denied? Oftentimes it's, for instance, incorrect codes or missing information. So, and all those again lead to better training for the people managing the claims process.
And I would imagine in those kinds of organizations, Anand, there's not a lot of IT resources available to solve these things. So, typical process would be submit a request to your IT team, get it put into a backlog. 6 months later, maybe they'll consider it. 6 months later, maybe it's built, who knows? Where if you could do what you're talking about, you get IT sort of out of the way, right? Like it no longer becomes an IT request. That's pretty powerful.
Indeed, yeah. The whole idea is this notion of data democratization, making it easy for the actual users of the data, whether they are on the administration side or clinical side or other aspects, other parts of the organization, to get the data they need to make decisions quicker.
Yeah, the other thing is, I've been involved in building a lot of systems, and so you build this report that you think is perfect, and then the user gets it and it's like, oh, I need these 2 more data fields for this to be useful, because they didn't know at the time, or things changed since the original request came in. And it seems like it would solve that class of problem pretty nicely too.
Indeed, yeah.
And yeah, so anyway, I think that's interesting use of AI technology. So what's going on behind the scenes there for the AI? Like, describe that a little bit.
Yeah, so different technologies come into play to actually provide that kind of a feature. So firstly, there's natural language understanding. So understanding users' questions in the context of the data available. So when somebody asks a question like, what's the average, say, bed occupancy rate or room occupancy rate in a certain wing, first the system needs to understand there's a concept called bed occupancy rate, and needs to understand, okay, there's a certain formula for it. And in order to calculate that, maybe you need to find certain raw metrics, or raw information around how many rooms are occupied on given days, and then use all that to aggregate all that to calculate this metric finally. So lots of technologies come into play here. So there's a natural language understanding the way users ask questions. Instead of saying bed occupancy rate, maybe they said occupancy rate of rooms or something else, a similar sounding term. Then there's a challenge of mapping those terms users use to an actual database, right? So in this case, there's a notion that we need to have a semantic model or an ontology that defines the different concepts that might be used in a given space in a universal fashion. So the interesting thing is that healthcare actually has among all the fields, it probably has some of the best and most comprehensive ontologies, especially in the clinical side. So lots of ontologies. The one big one called SNOMED, for instance, which defines all kinds of medical conditions and the causes and symptoms and lots of things. And there's slowly there are more and more semantic ontologies defining business terms as well. But yeah, so we need to understand people's questions. We need to have a model of the world, in this case, like an ontology or a dictionary of all possible terms. We need to be able to map users' questions to the terms. And then once the results come back, we need to figure out how best to present the answers back to users. So again, there's a technology called natural language generation, where we take, say, structured data and create natural language from it, so as to explain the results or explain the insights in an easier fashion back to end users. And sometimes that involves also generating charts on the fly so that people can understand, say, trends or anomalies better. So yeah, so a lot of technologies come into play to actually put together a system like this. So it's pretty interesting, but also fairly challenging to get it all working in a manner that end users with sometimes limited technological experience can use seamlessly.
Yeah, it sounds like there's a lot going on under the covers there. Thanks for sharing those insights. So we did have a question from the audience around the types of, I'm going to paraphrase here, the types of things that AI can do well versus the kinds of things that you probably shouldn't look to AI to do. Do either of you have some insight on that? Anand, do you want to go first?
Sure, yeah, I can do that. So AI does very well in narrow problems, I'd say. So if you can define the what it should predict or what it should give as output in a fairly narrow fashion with a well-defined and the answer is relatively well defined, then AI does a pretty good job. So as an example, so I used to work at IBM Research, in a previous life, and about 11, 12 years back, there was a man versus machine Jeopardy contest, and the team at IBM, they spent a couple of years building the system and fine-tuning it. But a big thing that they had going for them was that every question had one unique answer. So when they ask a question like what's the capital of some country, or in the Jeopardy fashion, there's one unique answer. In many of the situations, though, there's often a range of answers or multiple possible answers, and AI becomes a bit more tricky to use when things are more fuzzy, right? So that's where human intuition sometimes comes into play. So yeah, so if you're able to define, so problems where there's a single unique answer which can be well represented, those are cases where AI does well. When the answer is fuzzy and and it's not clear whether you're right or wrong, like in many kinds of clinical diagnosis especially, we have to use AI with a pinch of salt and get a human in the loop to take care of cases where the AI is not able to make a decision precisely.
So Lori, do you have any thoughts? Where to use AI, where not to use AI?
So pivoting, my background is healthcare. So pivoting to healthcare, a very similar situation that Anand was talking about, with a little bit of a twist. So one of the things that I've seen used both effectively and ineffectively was in claims processing. So when a claim is going through claims processing and it doesn't auto adjudicate and it drops out for desk review, sometimes it's very straightforward. And if it's straightforward, getting to a single answer, we can use AI to improve the editing process and then put them back into the claims processing and send them on. It's the cases that takes a knowledgeable personnel to make an informed decision on how to process the claim. And most of these people have to have years of experience. The good things that I've seen is we have been able to train and use ML to capture the actions that knowledge personnel has taken and build that in. Now, what we've also learned is what one knowledge person does and what another knowledge person does may be different. So we ended up needing to kind of run two scenarios and compare them and say, okay, what is the single answer? What is the right answer? So we use it as a training opportunity for our knowledge personnel to drive for consistency.
That makes sense. It seems like the other thing is you probably want to, if you're having AI that's learning or whatever, focus on recommendations and predictions and things like that versus, diagnosis or, trusting the result 100%, right? Because it's guessing. I mean, it's in a way guessing, right? I mean, honestly, doctors, are using that same process, but they're experienced. They've gone through a lot of training. They're not a robot, right? Like they have, educated. So their educated guesses are much, we can have much more confidence in them, I guess is what I'm saying.
So, and I've seen AI and ML in those particular cases too, and it's also been a kind of a similar experience in what the AI engine or the ML engine has done is they've given, say, a range of predictions. It could be this, it could be that, it could be this. And then I've seen what is typically called, a clinical corner where subject matter experts, clinicians will review that. They will compare their own individual notes and experience, and they'll compare that to the AI, and they'll see which ones are aligned, which ones make the most sense, what would each one of them do independently, so that then they can start to inform the AI and ML.
Yeah, that makes sense.
And in fact, it's a very similar pattern which is followed, in the world of self-driving cars, because that was one of the spaces where perhaps AI has made a lot of progress in self-driving cars. But the way a lot of the training happens is by observing lots of different people, encounter the same driving situation, and hopefully all of them respond in very similar ways. But then you can pick out the outliers. Somebody might speed up when they see a yellow light, whereas most people might slow down. But then you'll finally come to hopefully a kind of consensus that, okay, when you see a yellow light, what should the car do, right? So, but yeah, exactly the same procedures, are applied in lots of different domains, interesting ways.
Yeah, that makes sense. And it actually leads to like a final thing I wanted to talk about here is this idea of improving outcomes through, predictive analysis. Laura, you had mentioned something about that, when we were chatting. I don't remember the context, but can you talk more about that? I thought it was really exciting, a really exciting space to explore, and great use of AI.
Yeah, so being able to take the data and being able to capture at certain points in time of what is happening with the patient based on the diagnosis and the treatment plan and the effectiveness of the treatment plan, and taking certain metrics over a period of time, and then using AI to compare that longitudinal data across a cohort of patients and identify which ones are falling within expectations, which ones are falling outside of expectations, and if they see any anomalies over the period of time as to, did we see an indicator, at week 1, week 6, month 6, those different things, so that if we had that information and could start to see, did blood pressure increase, did blood glucose levels, bottom out, did the person was the person not drinking enough liquids and became dehydrated, any of those other conditions, looking for other factors, then the clinicians could have been warned, would have received early warning. They could have done a more intensive monitoring and direct clinical interventions, and perhaps the outcome could have been identified and avoided, actually, by making some changes in behavior or changes in, medication or something. So using AI to look at all the what if scenarios. because you can what if it all over. But we've been working on an RFP in upstate New York where they're looking for a particular population over a period of like 18 months and wanting to use predictive analytics so that they can deliver better health outcomes to that population. And so that's really very exciting, but it's all based on collecting the data and having the longitudinal information to make, you know, clinical decisions.
Yeah, it's very interesting. So go ahead, Anand.
Sorry, I was going to add, so I'd worked on similar problems at a much shorter time scale. So working, so before the current product is building, I was working on real-time analytics, where the goal was to predict situations based on real-time data, especially sensor data. So the scenario is typically around ICU settings where you have sensors to monitor heart rate and blood pressure and derive things like heart rate variability, as well as lab results coming in every now and then, and making use of all that information to predict conditions like sepsis a few hours before symptoms actually come up. So especially in some of those ICU scenarios where there's a difference in making predictions that can be made a few hours before the actual symptoms come in, could make a difference in life versus death, especially in things like sepsis, which I believe is one of the top killers in hospitals these days. You know, can promise a huge impact.
Yeah, so thanks for that. So there are some questions from the audience. Jill, can you ask the questions? I don't have access to see them right now.
I can, yes. One of the questions, it says, haven't other industries learned to work with data that is not well structured or well defined, like the investment management industry? Has the AI industry looked to other industries who've learned how to deal with this in the past?
Yes, a lot of AI algorithms, I think, are horizontal in the sense that once you figure out how to deal with certain problems in one industry, it often gets replicated in other industries. So one example I can think of is which I have a lot of familiarity with, is conversational AI, so chatbots. So the original use of chatbots was more around customer service. Right? So the first set of use cases that came for chatbots, but now it's for everything from even virtual doctors to virtual employee assistants to virtual HR. So now the use cases are exploding for chatbots, and we're using chatbots in fact to act as virtual data scientists. So yeah, so there's definitely a lot of once something is picked up in one industry, it is a lot of the algorithms and methodologies are often easy to replicate across other industries.
Yeah, and I would think there's common classes of problems too, like maybe I think you were just talking about one where you could look at network health in a software system or patient health in a human system, right? Like they're not exactly the same, obviously, and the risk or profile of that is totally different, right? But still, you can use similar concepts to understand that health and what possible things could help resolve those problems. So there's probably many areas like that, right? Like we could probably talk about that for 20 minutes. So just like where else can we see the common patterns? But they do exist, and I think once you identify a pattern, like you said, you can take those tools and apply it to other areas that have that same structure, regardless of the.
And in healthcare again, the lines are somewhat becoming blurred with fintech or fintech, in that we have the new No Surprises Act, and needing to be able to clearly predict to the patients what their fees are going to be. Okay. Mm-hmm. And so we are going to have to heavily rely on AI to help us with those calculations, because now it's federally regulated and mandated. So, so you're not going to be that person that went to a hospital that you thought was covered. Well, the hospital was covered, but the ER physician wasn't. So you get a 30 grand bill. Okay, no surprises. That's not going to happen going forward. So.
Yeah, so how do you detect those kind of conditions? And
right, and so AI is going to be hugely important.
Still, and the challenge there is do all of that quickly so that you still get the care that's urgently needed in that example, right? Like you can't
exactly
wait for another ER doctor to show up because you're not covered. Like, so yeah, there's a lot of like real-time challenges to deal with.
Mm-hmm.
Very interesting. Jill, any other questions from the audience?
One real quick question is HIPAA a help or a hindrance to AI?
Good question. I mean, it's a compliance thing, right? So it's not that different than it's talked about.
It's a necessary evil that we have to address.
That's well put. Yeah, I was going to say something in a similar fashion. It's at least given us a structure that going for that people can adjust around. I think the biggest thing is that it's as long as the process is well known and things are predictable, then I think people are creative enough to take the constraints that HIPAA imposes and then build on top of it. So the good thing is that there is a standard, as opposed to many other industries where there isn't a standard. So it's just in the last few years that things like GDPR and others have come in. But HIPAA has been around for much longer. So I think it's maybe given the healthcare industry some advantages in having this standard be available, and organizations can build on top of it.
Yeah, I have an interesting perspective where most, this is just my opinion, and I would love for you to validate this, but most AI processes work on anonymized data, right? Like they're aggregating data to make an answer. They're not using that specific data to they're not saying, oh, Anand had, this surgery and that's why we think this is the right answer, right? They're saying people had the surgery and this is why we think it's the right answer. And so I think, when you think about the spirit of HIPAA, I don't think it may not be a hindrance from that perspective. Now, accessing data and aggregating and loading data, like maybe there's some challenges there, but those challenges exist AI or not, right? So that's my perspective.
Right. So a lot of analysis can be done in the aggregate. I mean, the few things which are more difficult, especially if you have to say trace the timeline of one person's journey through different, say, conditions or through different events, those things become a bit more challenging. But in aggregate, it is possible. In fact, interesting analogy is with the whole mobile advertising world, where until like a year back, enterprises, so all marketers could track every single click and every single interaction made by people, and now they cannot, because now Apple and even Google have tightened up on that. So now they can only do aggregate, but still people have come up with ways of getting around that and still deriving interesting insights on marketing, web analytics with even aggregate data. So yeah, it's not necessarily a hindrance that certain kinds of things are more difficult, but there's always ways to work around it and get insights on aggregate data.
Awesome. Jill, anything else from the audience, or are we ready to wrap up?
We are ready to wrap.
Awesome. Well, with that, I want to thank our panelists, Anand and Lori, for joining us. Really great discussion, really insightful. And I'd also like to thank the audience for their participation and for joining us, because we do this for you. And without the audience, there's not a lot of point in doing these things. Thanks again to everyone, and we'll see you next time.
All right. Thank you.
Bye.
Bye-bye.